Hello guys, welcome back. We're talking lesson 4, which is all about constructors in Golang. You might ask yourself, we don't have classes, how can we have constructors? Well, there's a way. So the classic way to understand this is we have a standard way to declare constructors or create constructors in Go, and this will always be by returning a pointer of a type. This simply means our function name should start by new and then the rest of it, and then at the end of the day, you should always make sure you return a pointer to a specific type. I can explain this using a practical example to just make sure you grasp everything I'm saying. What are we going to do? We are going to create a constructor. And as I told you, the standard way to create it is our function name is gonna start by new and then whatever else we wanna put. So if I wanna create a new constructor, this is what I'll do. I'll do function and I put new. And now I can continue with everything I need. Mine is gonna take an ID as a parameter and I want to return a pointer. So what we are saying here is the constructor builds an account and returns its address as a pointer to that specific account. So we're going to return a pointer to this type and this. First of all, we don't have an account. So an account will probably be a struct, right? Because there's only built-in data type called struct. So I'll start by type. I'll put account and I'll put struct and I'll put here, and I can actually have an ID, which is going to be a string, but I'll also have a name probably, which is going to be a string as well. I don't have to put the columns. So now I have my type. In here, you can see it says missing return. So this is basically a constructor. I will go ahead and do this and build my initial. We're going to build my initial account. How can I do that? I'll go ahead and declare this over here, and I should have my account, and then I'll have here my initial values. The first one is going to be ID, which is going to be of type ID, and the second one is going to be name, which is going to be Galleon. So by knowing this, you actually understand that I can even change this by balance, so I can have more flexibility updating it. So you see that I can start by 1 and increment it. So I have balance, and this is going to be 0. So we still need a return. We have to return the address of this. So this concludes our constructor functions. How did we accomplish this? By understanding the definition that it is a function that returns a pointer of a type, and we are returning a pointer to a certain type here, and our standard way to define it is the function name starts by new. So now that we have created our constructor, we have to understand that by creating this constructor that returns a pointer of a certain type, this simply means the caller will have access to this instance, and they'll be able to mutate whatever we have here in our initial account. So let me prove that to you by going down here and creating an account. What am I going to do is I am going to call, because we already created an account here, I'm going to call my constructor function, and I'm going to assign it to a variable name called account, or ACC. And then from ACC, because ACC is gonna have this type as data type, so I'll go ahead and update or mutate through it because it's a pointer already. I can mutate this value. If it starts to from 1, it's going to be 1 plus whatever value, and then I can print also access and also access certain field. So what did I do? I called this constructor and pass in the argument and then store it in account ACC. And as you know, this returns a pointer. It means this is going to be of data type a pointer to account. So what happens over there is we already have a pointer. Using this pointer, we can go ahead and mutate the value through that pointer. As we already have one here, this is going to be 251. And whenever we print, we just dereference. By dereferencing this, we are going to be able to print that because this is basically a pointer to what? To account. So, but you'll notice that we don't have any dereference over here because dot access works on a pointer too. So that's very easy for us to do. If we go ahead and print this, I'll have to go back and here, so I'll go back here and put lesson. I'll go to lesson 4 and I can clean there. And if I run this program, you'll find out that this is updated my original account or the account initialized here. So the initial account has been updated by 1, and we have created a constructor, and we have created an instance of our constructor here. So this is simply the way you can like create a constructor and use it. And this concludes our session on constructors. So we are going to go ahead and tackle a real world example. Actually, it's in here. So I will also navigate over there. I'll do this and then I'll go to example, and this is going to be real world example, and I should be good to go. What am I going to do is I want you to see how our body, like the raw body, comes like when you submit a form on and you are using Golang on the backend. So this is how the slice of JSON bytes looks like. This is how you're dealing with. But looking at the fact that our Golang cannot use this as it is, we have to parse it. We're going to parse this body into a struct. How can we do that? We'll do it using our standard library, the JSON encoder. So, and how can we do that? We'll import that onto at the top here of our functions of our program, I'd say. And then the first thing that we have to do is we have to transform this into struct. So our application can use it. So I'll define my struct. Here's my struct. If you have followed other courses, you understand that this struct is just a type, and this type will bundle data that belongs together. And when you are creating a create order request, we know that all of these attributes belongs together. So what is our tag? This is something new you can see. What is it doing here? The JSON tag just maps our Golang to JSON keys. So what is it doing? It's saying whenever you see this from our JSON, from our body, refer to this in our code. Whenever you see this, refer to this in our code. If that makes sense, you already understand half of the stuff, because if you look down here, whenever this comes from our raw HTTP, we are going to be referring to this. That's what I meant by mapping Go fields to await JSON keys. And this is it as a comment. So below here, we are going to use the Unmarshal function. What does it do? What does it take? It takes two parameters. It takes two arguments. The first argument is the body. The second is a pointer to the request. Now we don't have a request yet. So let's create a request. And this is gonna be it's gonna be of type create objects. So moving forward, we can call our function and handle error, because this function will return an error and we want to handle an error if anything is wrong. So by doing this, we are able to handle the error. We have our if function. If you have an error, it's gonna return this message. It's gonna print this message and return now. So that's how we are handling the errors. But now we don't know what has happened. We have to go ahead and print, so we know that is this really helping us parse our JSON bytes into a struct. So let's find out by printing. We're going to go right there and print. So if you print over here, you will see like, yes, it is. Because look at this. This is what I was talking about when we said what we are doing here is we are mapping Golang fields to JSON. So whatever after marshaling this, unmarshaling this, I'm sorry, we went ahead and do what? And parse our body, our raw HTTP body into a struct, and that has happened. So what's the opposite of marshaling? Whenever now we want to send data, a response back to our front end, because our front end will literally understand JSON format kind of data. So what we are going to do is we are going to marshal it. And what are we going to marshal? We can just call the function marshal on our JSON standard library and pass in the request. And at this point, if we go down here and run the code, we'll see that we are having our JSON response over here. So this concludes the exercise or the example, practical real world example that we have over here. So I wanted your attention here because this is what you will see in pretty much every Go backend and anything dealing with APIs.